What's up, everyone? Welcome back. Moving on to the next example. What we got to do, we got to take this list of numbers here, and then we have to classify them. So we have to state which of these are integers, rational numbers, irrational numbers, real numbers, and imaginary numbers. And what's going to make this a little tricky is there's actually going to be a lot of overlap between these different groups here. And so what I want to do is quickly review that tree that we went over where we classified numbers. So I'm assuming that you have watched that video where we first broke down numbers into being either real or imaginary. And then the real numbers we broke down into either irrational or rational numbers. And then further, we broke down rational numbers to be either integers or decimals that repeat or terminate. And so notice that when we classify, for example, the integers, well, all of those numbers are also going to be rational numbers in this category, right? So I feel like drawing out this tree here is going to make that easier. And so what I would do is I would actually work up the tree. So start from the bottom and then work up. And so what we can do is we can go through each of these. So for example, 10, we know that that's an integer. So that would go right over here. Let me circle these. Right? What about the square root of negative 16? Well, the square root of any negative number, we know that that's going to be an imaginary number. So this here, we can rewrite as the square root of negative 1 times the square root of 16. Square root of negative 1 is I, square root of 16 is 4, so this would be 4i. Right? But we're going to leave it in the same format that we're given. So that's an imaginary number. Now what about root 3 over 3? If you remember, whenever you have the square root of an integer that is not rootable, then that's always going to be an irrational number. Even if there's other integers or rational numbers around, the square root of an integer that is not rootable, that's always going to be an irrational number. So square root of 3 over 3, that's going to be irrational. Negative 3 pi over 4, well, any pi that's around, that's also irrational. Remember, an irrational number is basically a decimal that doesn't terminate and doesn't repeat, right? It doesn't have a same sort of sequence as, for example, a rational number would have. So for example, 1 over 3 is a rational number. It's 0.33333. It doesn't terminate, but it repeats the same sequence, while irrational numbers, they don't terminate and don't repeat the same sequence. So negative 3 pi over 4, that's irrational. Negative 5, that's an integer. Let me circle these here. 1 over 3, that is a decimal that repeats. Remember, rational numbers, they could be written always as a fraction. So 1 over 3, negative 5 can be written as a fraction, negative 2 over 10, or negative 10 over 2, for example, or 10 can be written as 30 over 3. So any numbers that can be written as a fraction of integers are rational numbers. So 1 over 3 is here. Negative root negative 3, the fact that we're square rooting a negative integer or a negative number in general, that makes it an imaginary number. And then we have negative 1.4, which is a decimal that terminates, right? So that would go over here. It's not an integer, but it is a rational number because it's a decimal that terminates. Right? And so we have all the classifications down. And now once you have it labeled on this tree, it's easy to go through them. So notice that all the integers are what? 10, negative 5. All the rational numbers is going to be all the numbers under this heading here. So it's going to be all the integers, but it's also going to be these two values, the negative 1.4 and then the 1 over 3. The irrational numbers, we only have two of them, so it's the root 3 over 3, negative 3 pi over 4. The real numbers is basically all of these numbers under this heading here. So it includes all the irrational numbers and all the rational numbers. So it's going to be root 3 over 3, negative 3 pi over 4. It's going to be 10 and negative 5. It's going to be negative 1.4 and 1 over 3. And then the imaginary numbers, there's only two of them. It's the square root of negative 16 and then negative square root of negative 3. Right, so that's all the classifications. So again, there's a lot of overlap. That's what can make this a little tricky, but if you draw out the tree diagram first, then it makes that process easier.